All right, happy Wednesday. It's Miss Lastly and Miss Markert, and we are here for day number 13. And today's gonna be a little bit different. We are still, but we're and solving systems of equations, but we're gonna kind of set up our own system of equations. So it's a little bit of a throwback to sequences. So we're going to talk about a quadratic sequence, which is something that we skipped when we were doing our last unit, only because it makes the most sense to do this with matrices, because it does create a system of equations that we're going to need to solve. But yeah, so this is kind of, it's going to seem a little bit similar to an arithmetic sequence at first, because we're going to notice a pattern of adding instead of multiplying, but some weird stuff happens. So it's not exactly arithmetic. So it's definitely one to look out for. But I am going to turn over to Miss Markert so she can actually go through the notes with you guys.
Yeah. So yeah, we're talking about quadratic sequences today, and we're going to do an example, and then that will be it. It's going to be a little bit longer than it has been the past couple days, but it still shouldn't be too bad. It'll be fine. Okay, so we're going to talk about what a quadratic sequence is first, and this is a sequence where the second difference is constant between consecutive terms. So where second difference is constant between I can't spell, guys, sorry. Sure. Okay, consecutive terms. So what that means is when we're looking at this, oh, sorry, I jumped ahead. So our form for this is just any other, it's very familiar. You should all know what the form for a quadratic sequence is already. It's an squared plus bn plus c. It's just a quadratic. Should all be very familiar, or should be very familiar to you all. Remember that a sub n is your term number. Yeah, should be very familiar. Okay, so n is the term number, a sub n is what the number is for that term. So what the second difference means is we need to find the first difference first. So we're going to take the difference between all of our a sub n's really quick first. So we are going to have 2 here, 3 here, 4 here, 5, and a 6. And then we're going to take the difference again, and that is going to be our second difference. So then the difference between the first difference line is 1, 1, 1, and 1. And that means that we have a quadratic sequence.
So the a sub n right there, that's the actual sequence. So we're dealing with the sequence 3, 5, 8, 12. Like that's our sequence. Okay.
Yes.
I was just making sure.
Yeah. That's right,
yeah. Okay. So here's our sequence 3, 5, 8, 12, 17, 23. Right. So what Miss Markert did with that first difference is she just did what you would normally do to check for like arithmetic, right? Just subtract, like 5 minus 3 gives us 2, 8 minus 5 is 3, 12 minus 8 is 4. Perfect, right? So you can definitely see there's a pattern in that first difference. If it was arithmetic, those would all be the same number. Yeah. But they're not the same number, so it's not arithmetic. So if you go to that second difference, you see that, oh, well, the difference between first difference is the same number. That is the indication that this is a quadratic sequence. So only quadratic sequences will have that pattern, where not the first difference, but that second difference will be the same number every time.
Yep.
Cool.
So when you guys would have, if you guys would have had this mixed in with all of your other sequences, you would have checked first for arithmetic sequences, and then if they weren't all the same, you would check again the second difference for a quadratic sequence. Since we're just dealing with quadratic sequences for this round, I mean, they're all going to be quadratic sequences, but you can still check. It's a good habit to get into. We're not giving you any other sequences this round, so they will all be quadratic, but it's a good habit to get into just to kind of get used to seeing the pattern and getting used to checking. But spoiler alert, they all are quadratic. Okay, so then we're going to check and see if we can find the explicit equation, I guess, for this sequence. And then we're going to do one more example, so you kind of get 2 examples this round. So hopefully this will make sense by the end of it. Okay, so going back to our form, we have an equals an squared plus bn plus c. Again, should be very familiar. N is the term number. Okay, so going through here, we have n equals 1, and this is 3. So here, n equals 1, and it's 3. And then this equals a1 squared plus b1 plus c. And that will simplify just to 3 equals a squared plus b plus c. And remember, c is a constant, right? So just keep that in mind when you're doing these. Okay, so then we have n equals 2. So we have n equals 2, and that's 5. So 5, and then we have a 2 squared plus b2 plus c. And that one simplifies to 5 equals 4a plus 2b plus c. And then just for fun, let's do n equals 5. So we're going to get 17 is equal to a 5 squared plus b5 plus c, which we get down to 25a squared plus 5b plus c. Okay, so here's where matrix are applied to this. So we need to solve this system of equations over here. So over here, we have 3 equations and 3 unknown variables. We have a, b, and c. They're all unknown. You don't know what they are. So we need to go through and we need to solve that system of equations. And so that's where what we did yesterday comes in. So we are going to do our system of equations. So we have a 3 by 3 matrix. And remember, this is our coefficient matrix. So we're going to have 1, 1, 1, 4, 2, 1, 25, 5, and 1. And then our variable matrix, and this time we're going to have a, b, and c instead of x, y, z. And then our solution matrix, so we have 3, 5, and 17. Remember, you're going to do this in your calculator, so you're going to need to put in this matrix, find the inverse of that coefficient matrix, and then multiply it to our solution matrix. Make sure you're multiplying it on the left side of your solution matrix since it's on the left side of your variables. And then your answer should come out to a, b, c is equal to 1/2, 1/2, and 2, which means that your equation is an equals 1/2 n squared plus 1/2 n plus 2, just like that. So really the only difference today is that you have to find your 3 equations before you can put them into your matrix. But hopefully that makes sense. Yeah. Did I miss anything, Miss Leslie?
No, just so, because some of it can get kind of confusing when you're going through. Just remember the number, so n in that like quadratic equation that we're starting with, so a sub n equals an squared plus bn plus c. That's just your standard form for any quadratic, and n is equaling your term number. So the next line, when you see Miss Margaret taking like n equals 1 and saying that it's 3, that's because our first term, n equals 1, has a value of 3 in our sequence. So since we don't really know what those coefficients a, b, and c are, we're trying to find that. So usually when we're doing something like this, we're solving for the variable, but we don't need to solve for the variable. We already know some instances of the variable. So we're kind of working backwards, right? So we have the end result. We know what the variable is, but we need to find those coefficients. So we're just plugging in what we know. So we know that the first term is 3. So we're going to plug in 3 for a sub n, and then we can plug in 1 everywhere we have an n, and then simplify. So we're left with just 1a plus 1b plus 1c for that top line. Then we also know the second term. So when n is 2, we know the term is going to be 5. So we're plugging in 5 for a sub n, and then we're plugging in 2 for our n variable because it's the second term, and then we just simplify. Now, the fun thing about these is that that matrix that you're making with the coefficients, the ABC matrix, it's always going to be the same for the first, the second, the third term. Because when n is 1, 1 squared simplifies to 1 every time. So you're going to kind of notice a pattern. Now, if you look down at Miss Margaret's second example, you'll notice she doesn't give you the full sequence. She just gives you the terms she wants you to use. So then that coefficient matrix is going to change a little bit because we're looking at different terms than just the first, second, third, or whatever. But yeah, once you get your 3 equations, because remember you have 3 unknowns, A, B, and C. Therefore, you need 3 equations because that's how it works. If you have 3 unknowns, you need 3 equations. So once you have your 3 equations, you can pull out the variables, put it into your matrices, and then just use matrix multiplication to solve for those. So hopefully the second example will maybe make it seem a little bit more like you'll kind of get the pattern. But truthfully, it's just plugging in what you know, simplifying it, and then putting everything into a matrix to kind of solve from there. So let's check out example number 2.
Cool. In example number 2, I decided to be nice. So anyone who watches the video, this is actually homework number 8 today. So if you watch the video, you get a free homework answer. Okay. So for this one, Miss Lassley's right. I didn't give you the full sequence. I just gave you 3 terms of the sequence, but we can still build our 3 equations and then solve for the coefficients and the general rule. So let's start with that first one and build our equation. So we have A0 equals 3. So from here, we know that 0 is n, and then 3 is the beginning of your equation because it's what a sub n is equal to. So 3 is just the beginning of your equation. So we have n equals 0. And so we can write an equation as 3 equals a sub 0 plus b 0 plus c. And then we can do the same thing with a sub 2 equals 0. So in this case, n is equal to 2, and 0 is equal to a2 squared plus b2 plus c. And then we can do the same thing with a sub 6 equals 36. N is equal to 6. And so we have 36 is equal to a6 squared plus b6 plus c. Okay, and now we need to simplify all of these really quick. And my tip for you, since you guys saw yesterday and I got confused with where things go in the matrix, my advice to you is instead of simplifying this first equation as just 3 equals c, I would simplify it down to 3 equals 0a squared plus b, 0b plus c, just so that you can keep things straight in your matrix and you don't make mistakes. It's easier to see because you can see all of your variables written out there. And if you need to, you can even put a 1 here. If you're a visual person like me, that's probably helpful.
We don't need the square on the A though. That might be confusing. The A is just a coefficient. It's just a thing. It doesn't get squared. Just the 0 got squared.
Sorry guys, I'm used to writing quadratics.
Yeah, I know. I just didn't want them to think that when they plugged everything back into their equation that they would have to square the A value, because we don't want to square the A value.
Okay, and then for this one, it's just 4A plus 2B plus C. And then for this one, it's 36 equals 36A plus 6B plus C. Just like that. And then from there, again, we just build our matrix and then solve for your variables. So we're going to have our 3 by 3 matrix, and we're going to have 0, 0, 1, 4, 2, 1, 36, 6. Ooh, that's confusing. 36, 6, and 1. And if you notice here, our second line is the same as the second line that you can't see up here, because we used a sub 2. So our second line is the same. So keep that in mind if you like patterns and all that. And then we have our variable matrix, so A, B, C. And then your solution matrix, which is just 3, 0, and 36. And from there, you're going to find the inverse of your coefficient matrix. So let's label that A. Let's label this one B. So you're going to have A inverse times A times all your variables. I'm going to just put an X there as a placeholder. And then you're going to have A inverse times B. And you're going to end up with A, B, C is equal to 1.75, -5, and 3. Which means that your rule for this one is AN equals 1.75 n squared minus 5n plus 3. And there's the answer to problem number 8 on your homework. Yeah.
Cool. Yeah, so this is our last thing with matrices. This is the last thing that we kind of wanted to show you guys. We wanted to give you an application problem to kind of see when you would have like 3 systems with 3 unknowns kind of thing. And since we had to skip this last unit, it was definitely something I wanted you guys to see. So we kind of put it into this unit. And you guys can use your matrices to solve your system. It would have been really annoying if I made you do this by hand, so you're welcome. But yeah, so hopefully these 2 examples helped you guys. If not, we can definitely go over it tomorrow during our live stream. Hopefully we see a lot more of you guys there this week since AP testing is finished and that was your only excuse for missing it the last couple weeks. It's been lonely with just, you know, half of the class there. So hopefully you guys will be there tomorrow and we can go over another example of this, the quadratic sequences if you want. I think everything else this week should have been pretty straightforward, not too bad. But yeah, this is really it for matrices. This is our last thing that we're gonna do. And then next week, we're gonna go into review. So Monday, Tuesday, Wednesday is just gonna be a review of the different stuff we've talked about during matrices unit. And then for that checkpoint, you guys are gonna have like a test, right? Like covering everything we've done with matrices. And since you guys know how to use your calculator now, you can use your calculator for the whole thing. So that would be really nice. So we have this week's checkpoint, we have next week's checkpoint, and those are your last 2 checkpoints. So just a quick note, and we'll talk definitely more about this tomorrow, but if you're watching this video, I might as well talk about it now. You guys have until next Friday to get caught up on any of the checkpoints that you guys are missing. So if you took a couple weeks off because of AP testing, that's fine. I'm not upset about it. I won't count off points. I have not put the matrices checkpoints into the gradebook yet because not everybody has done them. We have definitely a lot less people doing them than I'm used to. So I'm just kind of waiting to give you guys some more time. I'm not counting any of them late. I know that you guys were doing AP testing. So I'm just kind of waiting for those to kind of roll in. So I'll probably put the first 2 matrices ones in together this Thursday instead of doing the first matrices one last week, just because there wasn't, I mean, there was like 70 like 5. Usually we're at like 130. So I'm just waiting for more to come in so I don't have to update as many times. But yeah, so we're really winding down, guys. So if you are a little bit behind, please get caught up. Again, we're going to talk about this tomorrow during our live stream, but if you're watching the video, I figured I might as well give it a little shout out so that you guys know that we are definitely winding down. It is getting close to the end of the school year and the end of our content. So if you are behind, please try getting caught up. But that is it. That's all I have for today. Hopefully this video was helpful. Hopefully you guys don't think these are too bad. I don't think they're too bad. But yeah, if you have questions, definitely make sure you let us know and we can go over them during tomorrow's live stream. All right, guys, we will see you tomorrow. Bye.